Number 17 says a negative 1/16 x plus 5 is less than a negative 1. Getting x by itself, I want to get rid of this plus 5. I subtract 5 from both sides. I have a negative 1/16. X is less than a negative 6. Because this is negative, I want to multiply by a negative to make it positive. I'm going to multiply by the denominator. The minute I multiply by a negative, what do I have to do to this inequality? It has to be flipped. So x is going to be greater than 96. And you would find that kind of about the middle on the right side. Reardon. Okay. So this one says 13 minus x is greater than or equal to 33. Pay attention to what I do, Reardon. I'm trying to get this x by itself. If I get rid of this 13, I have to subtract it. And when I bring this down, I have to bring the negative x down. Is greater than or equal to, and you're right, you've got a positive 20. I don't want to solve for a negative x. It's implied that it's a negative 1. I have to divide both sides then by a negative 1. When I divide by a negative, I have to flip my inequality. My positive divided by a negative becomes a negative. Number 11. 1 minus 5 halves x is less than or equal to 16. I still see a lot of people making mistakes when they go to get rid of this 1. Because they see this negative here, they think that they're going to add 1. If I add 1, what would it give me? 2. I don't want to add 1, I want to subtract 1. I still want to bring that negative down with my variable. This would be less than or equal to 15. I'm going to get rid of my fraction in 2 steps. I'm going to start by multiplying by the denominator. I'm going to multiply by 2. That leaves me a negative 5x is less than or equal to 30. X is being multiplied by a negative 5, so I end up dividing by a negative 5. When I divide by a negative, I have to flip my inequality, and this is going to be x is greater than or equal to a negative 6. Others from the worksheet that you want me to go over. David? Number 8. One-seventh x plus 2 greater than or equal to a negative 11. Getting x by itself, I've got to get rid of the adding 2. I subtract it. 1/7 x greater than or equal to a negative 13. Getting rid of the fraction, I multiply both sides by 7. This would cancel out, leaving me 1x, which is just x. Negative 13 times 7 is a negative 91. Please understand that I multiplied both sides by a positive. Did I have to flip the inequality because this was negative? No, only if I multiply or divide both sides by a negative. Okay? Others. Once, twice. In the space for number 46. Since we're not only going to write it, but we're also going to solve it. So, in your notes, write down page 46. And which number is this? Number 3. I don't want you to have to rewrite the whole paragraph, but I want you to know where this work came from. So make a note that it's page 46, number 3 on your sheet of paper, so that you're not taking the time to rewrite that whole paragraph out and we lose that time. But do you understand what I want you to do? Remember that when we're writing inequalities, that we're trying to compare two things. We're trying to compare two totals, two end things, two beginning things. Somewhere along the line, I want to make a comparison of two things. So, if I read this, it says the 45 members of the Glee Club are trying to raise $6,000 so that they compete in the state competition, state championship. They already have $1,240. What inequality can you write to find each amount the members should raise? Since there are 45 members, and I want to know how much each member should raise, I know that I can take 45 times x, and it would give me the total. Right? If I take 6,000 and I subtract 1,240, that would also give me the total that they need to raise, wouldn't it? It's always a good idea to ask yourself, could they make exactly that amount? In other words, could it be equal and they still be able to go? How much money do they actually have to have? 6,000. So they could make equal to that amount, correct? So I'm going to put the little equal part of my inequality there. Could they make less than that amount? No, they have to make what? More. So this would be greater than or equal to. Does everybody understand how I took the time to write the inequality? That's the inequality. And the only thing that we're going to add to writing it is we're also going to what? We're going to solve it because we have the ability to solve it. Now, we're going to take the 6,000 and the 1,240 and we're going to actually subtract them. So 6,000 minus the 1,240. And what am I going to do with that 4,760? I'm going to divide it by 45. Now, I will tell you that these problems, because they weren't designed necessarily to be solved, I'm going to come up with something like this. In relation to this problem, since each student must raise more than or equal to 105.77777, how much must each student raise, at least? What, here? It's greater than or equal to. 105 what? They have to raise $105.78. Now, sometimes these aren't going to round like you think they should round. Sometimes the whole decimal is going to drop off because you couldn't have a fraction of a person, right? So sometimes the whole part of that decimal is just going to get dropped. In this case, because I know that they need to raise at least $6,000, no matter what this decimal was, it would have to round up. Otherwise, they'd have fell a little short. But do you understand how we worked it out? Everybody okay? Everybody have it written, copy. I go to the next slide. Then this again is page 46. This is going to be number 4. Again, we're going to write the inequality. We're going to compare it. And we want to make sure that when we're writing and comparing the inequalities, that we're comparing like things, two totals compared to each other. Ella has $40 to spend. Admission is $6. Each ride is $3. Do I know how many rides she's going to go on? No. So I'm going to take 3 times X. I know that it costs $6 to get in. That's the total amount she can spend. 40 is also the total amount that she can spend. Could she spend all of her 40? So it could be equal to. Can she spend more than her 40? No. So it has to be less than or equal to the 40. There's my inequality. And then we're going to do what? We're going to solve it. If I'm getting the variable by itself, I'm going to subtract 6 from both sides. I have 3x is less than or equal to 34. I'm going to divide both sides by 3. X is less than or equal to 11.33, repeating. In terms of my problem then, what does that mean? She can go on at most, what? 11 rides. Even though this was 0.333, it's not possible for me to ride part of a ride, so that decimal just dropped off. Everybody understand? Everybody got a copy? I want you to turn all the way to the back of your packet then. This would be page 50, very last page. Yeah, you can actually write this right on the paper. I just wanted to make sure you understood how to do one of these types of problems. And which number is this? It's number 17. Okay. Here they're saying write greater than, less than, greater than or equal to, or less than or equal to in the blank. And they're giving you a word phrase in front of it. And I really recommend that you look to see if it can be equal first. That's the easiest comparison to make. It says k is no greater than 9. So you ask yourself, is 9 greater than 9? No, so it's okay. It's right. It can't be greater, but it could be what? Equal to. If it can't be greater, it must be what? Equal or less than. So all you're doing is filling in that space with that proper inequality. Everybody get it? Everybody think they're ready? Because that's your assignment. Seven through 25, skip number 15. Because 15, they're asking you to write a situation for that, and we'd have a million different answers. No, you're going to start on page 49, and you're going to start with number what? 7.